Now, what are the measurement of the value at risk? How we measure that value at risk? So there are the three methods we have the value at risk. One is the historical simulation method. So here we have seen that what is the use implication we have of the value at risk. Then the next task what we have, how to measure the value at risk. There are the three different alternative methods we have to measure the value at risk. One is known as the historical simulation method, variance covariance method. It is also known as the analytical method, or sometimes it is also known as the delta normal method. Third, we have Monte Carlo uh, simulation method. So these are the three approaches, three methods, alternative methods we have through which we can calculate the value at risk. So let us see in detail one by one. So the first we will talk about the historical method, which is a theoretical and one of the simplest method we have. So it's not based on the theory. Basically, in this case, what we do, we use the historical data to find out the possible loss. So here we do not assume any distributional pattern about the historical. So we use the historical returns to estimate the future losses here. So basically what we do here, we collect the historical data, return data, then we sort the returns in the ascending orders, then identify the return at the desired confidence level. So let us take an example and it will be clear, because this is one very simple and easiest method to calculate that. So let us say we have the portfolio detail like this. The portfolio value is rupees 100 crore and the confidence level 95%. So at that uh, probability level we wanted to estimate the value at risk. And the historical returns, let us say we have the 10 days historical returns. Here just for the example we are taking. So most of the time we take at least 2 year or 3 years historical return. So these are the historical returns we have. So this is the first 10 day. Now if you wanted to calculate the value at risk at 95% for 1 day, or what we can say 1 day 95% value at risk for a portfolio whose value is rupees 100 crore, then the first task what we do, we sort the return. So basically we sort the return in the ascending order. So the lowest more than the previous one, more than the previous, more than that, more than that, and here we have this. So basically we arrange in the historical ascending order. So the first task what we do, we sort the return in the ascending order. So here we can see that we have the minimum, then higher than that. So here we have this basically should be 0.005, 0.005, then it should be 0.01, then it should be 0.015, and it should be 0.02. So that's the basically ascending order we sort the return. So once we sort that, then we identify the confidence interval that so here since we have the 95%, so that's why we identify the 5 percentile we will be calculating. So we know that at the 95% confidence interval, the 5th percentile corresponds to the second lowest return, that is this. Now what we have 0.02, or we can say minus 2%. Now we use that to calculate the vector value at risk. So that is the simple, we are using this into the portfolio value, which is equal to 2 crore. Basically it will turn out to be minus. However, the negative here, basically implicitly we are assuming that we are talking about the loss. So that will be obviously in the negative value. Therefore, we have multiplied with this in the minus, and therefore we usually show with the in absolute value terms. However, the actual calculation will get minus 2 crores. So that will be the loss for 1 day. So this is the historical method we have. So we can interpret that 1 day where that is value at risk at a 95% confidence level is rupees 2 crore, or what we can say, there is the 95% chance that the maximum potential loss will be rupees 2 crore in a single day, or we can interpret that there is a 5% chance of losing more than rupees 2 crore in a single day. So, any of these three way we can interpret this value at risk figure. Then next we can generalize this approach. Here we have taken the numerical specific cases, so we can generalize. So, the generalized method is simply we have the n historical returns, which is R1, R2 up to Rn. Then we sort those returns in ascending order. Then we identify the value at risk at 1 minus alpha to the power multiplied by n here. So, here alpha is the confidence level interval. So, it will be 1 minus n. For example, we have 95%, then we had 1 minus 95, that is the 5 percentile we had. Then historical return at the percentile threshold we calculate and we multiply with the portfolio value, and that will be the exact value at risk using the historical simulation method. Next is the variance covariance method. So, here we assume that the distribution of the returns is a normal distribution. So, in the previous method we have discussed, that is without any assumption about the distributional pattern. Here we do assume that it follows a normal distribution. Second, we are assuming that the portfolio relationship is linear and the volatility and the correlations among the assets are constant over time, that is the returns are stationarity in nature, which already we have discussed in the previous lectures about the concept of stationarity. Now, in this case, what basically we do in the variance covariance approach here? In the variance covariance approach, basically we assuming that the return follow a normal distribution. And from the normal distribution, we know that if we have the normal distribution, in that case 95% confidence interval, at this point what will be the value of this? We know that the value of this will be minus 1.64. So, if that means any value of this is the maximum loss we can get. So, that is what is the value at risk. And from this value we get from the z distribution of normal distribution. So, in case of normal distribution, we use the value of z to identify the value at risk, because we know that every percentage level, every confidence interval level, what will be the value we can get from the distribution of normal distribution value. Now, let us say if we have 100 crore, in that case if we have the 95 percentage, then we know that at 1 crore we have the loss of 1.65 crores. So, that is the loss we have. Now, if the value of portfolio is 100 crore, so this, why we are assuming this? Because we know that in the standardized normal distribution curve, this is the total value of this distribution will be basically 1 if we integrate. Then here this is the basically we know 1.64. So, that multiplied by basically 100, and then we will have the value at risk of this. So, to better understand that, so we can generalize that here. Portfolio under the variance covariance method is calculated like this, where what we have, Z is the G score corresponding to the confidence level, for example 1.65 for 95% and 2.33 for 99%. These are the values we can get from the normal distribution table. Then this sigma p is the basically standard deviation of the portfolio, and this t is the basically time horizon or the holding period. So, using this particular formula, we can calculate the value at risk. So, how we calculate this portfolio variance covariance? So, that we can use calculate using the variance and covariance matrix, where W is the vector of the portfolio weights, sigma is the covariance matrix of the asset returns, and portfolio standard deviation we can get obviously in the square root of that. So let us see here. Then the next we have to have the Z score for the confidence level, and we can get from the normal distribution table here. For example, let us say we have the portfolio whose detail is given. We have the two stock assets, stock A and stock B, and combining those two we have created a portfolio, and the weights of the assets are the 0.6 and 0.4, and these are the standard deviation of the individual assets. And the correlation matrix is given. The portfolio value we have the rupees 100 crore. So 100 crore has been invested into the two stocks, stock A and stock B, where the information how this 100 crore has been distributed according to this weight. And these are the information we have about the stock A and stock B and time horizon 2. Then how we using the variance or covariance matrix, we can calculate the portfolio standard deviation. So once we are able to calculate this, it is easy to calculate the value at risk. So this is the basically what we have. We have this particular formula for value at risk, where Z is the basically value of the Z score, sigma p is the standard deviation of the portfolio, T is the holding period time, and portfolio value, this is the value of the portfolio. So here we have 95%, that means 1.65 multiplied by standard deviation, this is 0.13, and multiplied by the square root of the time and multiplied by the value of portfolio, and ultimately we have 17.14 crores. That means the one day value at risk at a 95% confidence interval is rupees 17.14 crores, or we can, this means that there is a 5% chance of losing more than 17.14 crores in a single day for this particular scenario here we have. So what are the advantages we have? It is easy for implementation, assumes the normality of the distribution. However, it is also assumes a static correlation between the assets. Then the third method what we have the Monte Carlo simulation method. However, it is being often used when we do not have a large historical data so that we can estimate the future loss. Because in the last two cases, what we have done, we have used the historical data to calculate the value at risk. In case of historical simulation, we have used directly. However, in case of variance covariance, we have used those returns to estimate the volatility. That's why in the previous lectures we have discussed that we use the different models to estimate the volatility, which will be being used for the portfolio optimization, or to find out the value at risk, or to quantify the risk. So in the previous example what we have seen, we get those variance and covariance using the different models which uses the historical returns. However, if the historical returns is not available in the sufficient numbers, or we do not rely on those models, then we can use the Monte Carlo simulation approach to estimate the value at risk. So in this approach, basically we use a random sampling approach to calculate the expected loss. In these previous two methods, we use the previous informations to estimate the loss. So here, but this method apart from that also has a certain other advantage. First, it can handle non-linear relationship. In the both the previous methods, we have assumed that the relationship among the assets are linear. However, here it is not necessary to be a linear. Second, we have assumed the returns follow the normal distribution. However, they assume a complex distribution here. So it does not rely on the normal distribution. It can incorporate fat tails and the skewness as well, which is the stylized fact of the financial variables we have. So this is, in that terms, it is assumed Monte Carlo simulation method is assumed better than those two methods. Another thing, because it is based on the simulation, so we can simulate for the different scenario. So we can use the scenario analysis. Okay, what will be the maximum loss at the different conditions or situations. So what basically we do here? So we can list out the steps like this. First, we define the portfolio, we specify the value and the composition of the portfolio. Second, we model the asset returns because we do not have. So, here whatever the either we can use the historical data if we have, or we can use the some stochastic model to generate the asset returns. Then to generate the random scenario, then calculate the portfolio value at the end of the each time horizon. Once we are able to know that, that means we will be able to calculate the profit and the loss. Then we make the distribution of that profit and loss, and we will be able to calculate the value at risk. So, in summary, basically what we do, in the beginning we have the portfolio value, then using the random sampling approach, or what we can say through the simulation, we find the value of portfolio at the end of each period. Then using the portfolio of the initial, let us say here star, and here we have at the end, let us say we are putting E here. So, we use this portfolio value. So, the portfolio value at the end and the portfolio value here in the beginning, we find out either the profit or the loss, and this because this ending value we have calculated using the simulation. So, we change the scenario here, then we will have series of ending values, and once we have the series of ending values, then similarly here we will have series of profit or loss. Then we find out the distribution of this profit and loss, and using the confidence interval, given confidence interval, we can find out the value at risk. So, this is the basically again a simpler approach we have. Now, let us say certain facts about the value at risk. First, how the value at risk changes, what are the factors it could change. First, if we change the holding period, so from the formula we can see here, it comes square root of t. So, that means if the holding period changes, the value at risk will change, and that is intuitive also. When we say the value at risk, let us say rupees 10 crore for a particular portfolio for 1 day, that means we are going to lose the value of the portfolio during 1 day. However, let us say if you are holding the portfolio for the next 2 days, so obviously the value of that risk of that portfolio will change. It can't remain the same. So, therefore, it is intuitive also, and from the formula also we can see as we change the time horizon or the holding period, the value at risk will change. The second, if we change the confidence interval, then also the value at risk will change, and that we can easily find out from the normal distribution here. So, if let us say it is the 95%, then obviously if we change, let's say 99%, so here the value will change. So, therefore, the confidence interval if changes, the value at risk will also change. Third, if we change the portfolio, then also the value at risk will change. And the fourth component we have, if the volatility of the portfolio changes, again the value at risk will change. Therefore, the estimation of the correct volatility is very important to have a precise and the better estimation of the value at risk. However, in case of value at risk, we have the certain issue. So, what the value at risk says that Value at risk says that if we make the distribution of the return, and here we have, let us say, this case, then it says that, let us say the 95%. So this will be the maximum possible loss if it is follow a particular normal distribution. However, what if the abnormal returns, if the loss, let us say here we have one return like this, there is less chance that it will cross this. However, if in the certain extreme cases it crosses, then this loss will be more than this value at risk. So those extreme value which occurs, we are not able to capture into this particular measure of value at risk, either being whether it's simulation Monte Carlo simulation method, or the historical method, or the variance covariance approach. In any method, through the concept of value at risk, we are not able to capture the extreme loss cases. Therefore, what we have another measure what we know as the conditional value at risk. Basically, it's an extension of the value at risk. So, conditional value at risk is also known as the expected shortfall. It basically is a risk that measures that the estimates of the expected loss of a portfolio, if the losses exceeds the value at risk, so threshold, then what could be the maximum loss. So let us say here we have this distribution. So here we have the value at risk. Then what is the chance that the extreme value case will be here? So to calculate that, we use the conditional value at risk. So primarily it focuses on the tail risk and it gives the more risk sensitivity. And we use this particular formula to calculate that. So here basically what we do, if let's assume that loss distribution is L and the alpha represents the confidence interval, and then conditional value at risk could be calculated using the formula where we have expectation of L, the distribution, to be more than the value at risk at the alpha threshold. So EL is the basically expected value and VAR alpha is the value at risk at the confidence level alpha. Or this could be also calculated using the integrated or the probability density formula. However, the both will give the same value here. So for example, let us say we have the conditional value at risk 95% is minus 2.06. That means if the losses exceeds the value at risk threshold of 1.645, the average loss could be minus 2.06. So that's why it calls conditional value at risk. So it is conditioned upon the value at risk threshold. If the loss crosses that threshold, then what could be the possible loss? So we have the value at risk a threshold. If there is chance to cross that, if it is exceeding that, then the chance is we will lose 2.06 crores if it is in the crore terms. So thank you so much. So today we have discussed the value at risk measure, what is the implication we have and what are the different measures we have. So in the next class, we will implement the concept of value at risk and we will also discuss about the different case studies of the event studies.